Right now we're going to talk about technology and how the drought is going to make California rich. I'm actually not kidding. So we've fashioned California into an agricultural giant, and we've built some of the world's greatest cities through monumental feats of engineering, from the Hoover Dam to the LA Aqueduct and the State Water Project. Today, that centralized water system has caught the West in a Gordian knot of huge sunk investments and behemoth government agencies. Untying that knot is going to be the defining challenge for the West in the next decade. As California grows and its water supplies dwindle, the West has no choice but to pioneer new approaches to water management. Water has built the West, and how we deploy water innovation will define our future. They've already talked today about the fact that more than 50% of US municipal and wastewater infrastructure is nearing the end of its useful life. An estimated 240,000 water main breaks per year. Federal funding for water utilities has fallen from $16 billion in 1976 to $4.3 billion in 2014. It's been passing that burden of maintaining water onto states, municipalities, and obviously, at the end of the day, the ratepayers. Water has gone up in price by 6% nationally since 2000 each year, and sewer rates have gone up 20%. Clearly, they've also failed to cover the costs. So market analysts are gleefully predicting this great boom in infrastructure investments. They're looking at $432 billion over the next decade. They look at the very expansive pipe network. They look at combined sewer overflows. They're looking at rising populations. But what they don't talk about is where that money is going to come from. At the same time, we're also seeing regulatory pressures mounting. An estimated 42 million Americans are living in cities under consent decrees for the Safe Drinking Water Act. So if 21st century water and engineering can stretch the water we have, both that we're importing, but also the water that we have around us, the technology is not that monumental, beautiful site that we were just looking at. It's distributed. Here's an example of WaterPlanet's installation. And as you see, it's a plug-and-play kind of solution that blends in with its environment. With advanced technologies, buildings can actually wear their water infrastructure, and they can blend into their urban environment. Here, San Francisco's Public Utility Commission has made its new headquarters a centerpiece for the city's strategy for future-proofing its water system against earthquakes, against climate change, and against drought. Distributed solutions work reliably and resiliently on site. They combine filtration as well as biological wetland structures right in the middle of San Francisco. The SPUC has spent more than a decade building a partnership between the health department, urban planning, and its water department to develop these distributed systems. Here's a system schematic of that specific system, and it provides a view of some of the moving parts. This is a view of that quote-unquote wetland, and it's installed as a green space right on the street here in San Francisco. So to survive, California is going to need to do more than stretch the limits of engineering and science. It needs to deploy new financial models, new policy, and integrate water with the energy infrastructure. We need to decide what parts of our great tradition we're going to tap into and what parts we're going to leave behind. Even with an arsenal of proven technology solutions, we need a new vanguard of leadership to redefine water in the West. So for this panel, I've invited three of the individuals that I see as representatives of that vanguard for 21st century Western water. Each of them bring decades of experience that guide their approach in deploying water tech. We have Howard Brewen, who's the superintendent for the city of San Luis Obispo's water resource facility. Eric Hoek, the founder and CEO of WaterPlanet, and Paul Gagliardo, head of innovation at American Water. With the help of this panel, we're going to introduce some of the critical issues for reimagining Cadillac Desert and provide a view of some of the early successes in real-life projects. To round off, we're going to discuss the potential impact of advanced technology in the West and the policy and business innovations that are necessary to move things forward. I'm Laura Shenkar, the founder and principal at Artemis Water Strategy. Artemis is an advisory firm that supports wide-scale deployment of advanced water technology through work with leading corporations and utilities, as well as water equipment companies and investors. We focus on the near-term opportunities for deploying advanced solutions. We track technology beyond the science and engineering to look at costs and benefits, at project management and permitting, and also the bigger picture in terms of sustainability. Clients include Walmart, Intel, IBM, and the US Navy, and our work spans from Israel to Singapore to Canada, as well as in the US. We leverage a network of 300 industry experts to map emerging leaders in water tech. Our Water Tech Top 50 has identified over 1,000 companies worldwide that are relevant startups entering into that market. So here's the good news. As we talk about the drought, unlike renewable energy, unlike IT, this is a market where the investors can't find enough opportunity to invest. Water investors are hungry for new investment opportunities. Our woes in terms of water are actually a huge asset for innovation. If you look at the world, the largest funds, sovereign wealth funds, endowments, pension funds, are struggling to find tech-driven water. These funds look to preserving their wealth not over a year or a decade, but over centuries. And they see water scarcity looming as a major risk to their investments. Many of the blue chip stocks that you see, Intel, Coca-Cola, rely on water-intensive manufacturing. For every dollar invested in semiconductors or food, investors are more vulnerable to water risk. Norway's $877 billion sovereign wealth fund holds an average of 1% of every traded company worldwide, and yet it has identified that 11% of its portfolio companies face a direct risk based on water scarcity. According to the Carbon Disclosure Project, 2/3 of the world's largest companies are reporting exposure to water risks that could generate substantive change in their businesses. So tech solutions and the projects that apply them provide a hedge that investing in water rights or big infrastructure companies cannot. Technologies are going to be thriving as water becomes more scarce, as it moves the needle in terms of operations. But despite a vibrant crop of startups, none of these startups have been able to really break through and redefine water at a market scale. Major cities are continuing to spend a bulk of their budgets on centralized water. For example, DC is investing most of its capital budget on a $2.6 billion Clean Rivers mega project. Here are some of the views of the monuments that built the backbone of Western water. This is circa 1931. And here are the views of the monuments that are building the backbone of DC's 21st century water system, circa 2015. This is a giant tunnel boring machine that is digging subway-sized tunnels of that are more than 100 feet underground to stem the combined sewer overflows that area has been suffering. The machine has a 20-foot-6 diameter and is longer than a football field when assembled. It is so big that they've named the drill itself, they've named it Ladybird, for Lady Bird Johnson. So as you see, there is a stunning similarity between these pictures and the pictures from 1931. With such urgent problems and looming economic risks, why has it been so difficult for advanced technologies to gain momentum? Simply put, water is too cheap to pay for itself today. And in the US, it is not ever going to get very expensive. Providing clean, healthy, affordable water to communities and to businesses is one of the basic responsibilities of any government. With water so cheap, most property owners and cities simply can't justify an upfront capital expense to retrofit their on-site systems. And even when they can see a long trail of savings beyond that. And distributed infrastructure needs more than finance. People in the US want the same kind of utility oversight that they have with centralized water. California water utilities need to evolve with the same systems to ensure that they provide healthy water and sanitation. Where our existing municipal finance structures have funded centralized water over the last century, we need a new breed of investments to unlock the market for distributed water. Among the most promising models are third-party finance vehicles adapted from solar financing. Finance vehicles group a series of smaller projects into single investments of $20 to $100 million. These distributed projects partner with utilities and offer water infrastructure as a turnkey service to property owners. Many of the most promising opportunities for infrastructure as a service pay for themselves based on energy savings or even energy generation. Here's one example that Artemis has put together for Generate Capital in Washington, D.C. In partnership with DC Water, a series of on-site projects provide wastewater thermal energy that replaces conventional heating and cooling. Property owners like this DC school pay for this low-carbon HVAC as a service based on their energy and water savings that they get from eliminating conventional HVAC. Wastewater thermal energy provides a new source of resilient renewable energy, and DC Water is projecting that it can generate 200 megawatts of power through their existing sanitary system. DC Water charges for the use of this thermal capability and therefore generates new revenues that supplement its operating budget. California cities, like San Luis Obispo, we're about to hear from them, are caught in the same kind of dilemma: dwindling water supplies, evaporating water revenues, and escalating costs. Howard Brewen is going to speak about how they're addressing these challenges. Distributed water is going to do more than just help us tackle a water problem in a drier, more crowded future. It's going to drive our economy. Distributed water projects require developers, skilled hands-on workers. By leading the US in implementing distributed water systems, California can nurture water tech companies, just as we have with solar energy companies. Over the last decade, there were nearly $48 billion in documented investments in renewable energy, energy efficiency, transportation, and other climate projects in California that resulted from California's climate policies. These policies have created 500,000 jobs. Here's the estimated impact for San Luis Obispo's District 35, 7,000 jobs and almost $1.9 billion in investment.
So it's interesting, I don't know if a lot of you know where San Luis Obispo is, it's on the Central Coast, and the previous speakers, it's been quite fascinating for me. A lot of districts here. I have a lot of respect for Orange County, San, Irvine, Metropolitan Water District on being leaders of our industry. But the vast majority of municipalities and districts are not them, they're me. And it's interesting, our problems are the same, but our approaches a lot of times need to be vastly different. San Luis Obispo does not have the luxury of importing water at all. We really rely on a surface. And so it's forced us to really look at things differently. And I will tell you that I've never been more excited to be part of this industry than today, because as bad as this drought has been and may continue to be, what it is doing is forcing us to look at a completely different paradigm. And that's exciting. We don't get that opportunity very often. We don't get an opportunity to start really fast tracking things. So on technologies, which is really, I could go on the other deal, but on technologies, if you really look at it, I always thought that technologies were the innovators. They were the movers. They were the movers and shakers. But what I've come to realize is that they've moved way ahead of us. And the fact is, people in my position, people that were on the panel previously, for better or for worse, we're the gatekeepers. And I believe we're the problem. It's not the technologies. We have to shift our paradigm. We have to shift our paradigm 180. And so sometimes, you know, from my position, technologies companies will come in, they'll do marketing, they'll do sales, and I look at my desk and I'm piled this much with work and I'm going, I just don't have the time. But then I really think about it, I don't have the time for what? I don't have time to invest in the future. I don't have time to change the paradigm. I mean, so for our seats, I really think we have to not so much maintain and manage as a big part of what we do, but we really need to be innovators and leaders. And it's hard to wear that's two different hats and it's two different approaches. If we do not sit back and understand that we are the problem, we're the ones that is not letting this technology in. And it's a paralysis of fear that I believe is keeping us from that. Metropolitan, Jeff talked from there on, we've done such a great job on delivering water reliable, and we concentrate on that. But in that concentration, we start narrowing our other deal because we're just like, okay, we have a system, this is what we do, we deliver water, it works. But sometimes we get so focused on that little narrow sliver, that it doesn't allow us to, a gentleman asked earlier, he goes, why don't we just blow up this system? Why don't we just do something else with PPAs? Laura's Artemis technology, there's another great deal. So I think there's not one silver bullet here. What I do believe is what San Luis Obispo has done is we have, let me click the slide here. So if we were in a room today and we were talking about technology and I had my engineers and I love engineers and some, but I may end up dishing a little here on them. And we were looking for a solution. And they had this up in front. I'm going to tell you how the conversation in the room would go. Well, Howard, those lift stations, what's the pump capacities and how old are they? And You know the most two important things on this slide? And I'll bet you hardly any of you got it. You got buried in the numbers. One, water, and resource. That's the driver. That's where you need to think from. You need to think there. That other stuff will take care of itself, but we just go back to what we know. Here's the other thing. We talk about triple bottom line. But I'm not sure we really exercise it in our decisions and our decision-making abilities. Because if we really looked at this, I think we would start really looking at these new technologies and bringing them in. Because we're the custodians of the ratepayers. And so we tend to look at return on investment and that. But I'm going to tell you, we're in a world now that is beyond economics. Absolutely beyond economics. And I believe if we would really, really look at a triple bottom line and base our decisions on that, I think the outcomes of bringing new technologies at a much faster track into our industry would happen. Here is one of our mantras in St. Louis when we get together and we're trying to advance something. Everybody has a role in that room. Maybe an engineer, might be an IT person, might be an accounts person. And it's interesting when you're bringing new technologies in, the first thing everybody says is why it won't work. And I absolutely do not allow that in that room. Please tell me what will happen if it does work. Please tell me all the good things that can come out of this. And then we'll work our way. And that simple shift, you would be amazed how it opened up to everybody's mind, because you as a finance manager or an IT person may say, well, you know, if we allow that type of integration and we don't have enough firewalls, they're just talking about what they know. I want them in the room to know that, but I also want them to go, time out. What if? What if?
Thank you, Laura. Thank you all for being here, and BB&K for organizing this event. Very cool. So just a little bit of background. I've worked on the East Coast as an environmental engineer at Merck, a pharmaceutical company, where it was our job to make sure that the drugs that they were making and the R&D that they were doing were done in a safe manner from an environmental perspective. We managed waste incinerators, pathological and solid waste. We managed wastewater treatment systems, air pollution permits. I've been a UCLA engineering professor. Was a professor for about 12 years. I've been an entrepreneur. I've done a lot of consulting. And I've also been involved with some philanthropy in Africa and Fiji, bringing clean water systems and education on sanitation and hygiene and water issues. So I've got a pretty diverse background, but it's all around water. So I like to refer to myself as a water guy who looks at the world through the lens of, well, that's great, but couldn't we do better? And so that's where everything I do really comes from that perspective. So if you think about available water resources, someone can correct me if I'm wrong, but as best as I can determine, the only water resource that increases with population and increases with industrialization is wastewater. And we've heard this morning about climate change and drought and water reuse, and we need to do more storage and distributed systems, and there's resistance to desalination for various reasons. We need to remediate our local groundwater, stormwater harvesting. We need to adjust the pricing of water. We don't have enough federal investment here. I heard talk about smart water systems. We don't know enough about where the water is, where the leaks are, how to control it. Agriculture, massive water users, Peripheral Canal, Endangered Species Act, and water neutrality for new developments. At the end of the day, you know, as you heard, to become self-sufficient here in Los Angeles, to rely on local water only, we're gonna have to do massive amounts of water reuse. And to do that, essentially, it boils down to the heart of the process to enable water reuse is membrane technology. We can do conventional biological treatment, which you see in the picture on the right. And the inset is a picture of a membrane that's being pulled out of a membrane bioreactor, a kind of technology that can be used to convert municipal sewage into Title 22 type landscape irrigation water. Non-potable, but it's the kind that goes through the purple pipes and irrigates golf courses and the highways all around Southern California. Is used in industry as well. That reuse can be industrial recycling, reuse can be, as I said, Title 22, indirect potable reuse, where we take the wastewater, we repurify it through microfiltration, reverse osmosis, UV and other oxidation processes. Or we're now starting to talk about direct potable reuse. The state just published a report on how to go about establishing guidelines in California to implement direct potable reuse. So water reuse is here. It's been here since the 60s and 70s. It's grown massively in the last 30, 40 years here and in other places. But still around the US on average, only maybe about 4 or 5% of our wastewater is treated and reclaimed for reuse. So we have a huge delta between what we are doing and what we can do. And as I said, membrane technology is at the core. And the problem with membrane technology is when you put these dirty, nasty waters, try to filter them through the membranes, they get fouled up. Now, fouling is sort of, it's like a filter getting clogged. It doesn't sound like a sexy subject to be talking about. But it's been paying the bills for me for about 20 years. So what we do at WaterPlanet, we started the company about 6 years ago now. And the original idea was to develop some next generation technology, membrane-based primarily, but the focus initially on industrial water recycling and reuse. There are just vast amounts of industrial wastewater that are generated that are just sewered or discharged or injected into deep wells underground and not treated and reused. And our approach, we have 2 core technologies that we've developed. So one is a new membrane material. I'll just talk briefly about the technology. I don't want to get too deep into it, but I'll tell you why we did what we did and what we're doing with it. So the membrane material we call Polycera, and a controls technology we call IntelliFlux. And you can read the words on the slide. At the end of the day, we can put IntelliFlux as a software. You can put it on any existing or new filtration system. And relative to what that system can do with the standard set of controls, we can save 10 to 20% of the operating cost. Lowers the energy, reduces the chemicals that are used, reduces the downtime, maximizes the uptime, makes the process more efficient. And it's a simple software patch. Not so simple, but simple enough to implement. The membrane material comes from Nobel Prize winning chemistry that we didn't invent, but we've taken and we've developed further into a membrane material. And the membrane brings to the industry, for the first time, a material that has the robustness and the resistance to fouling, bacteria and oil and things sticking to the filter, like ceramic materials do. But it's 10 to 20 times cheaper than ceramics because it's a plastic material. It's very unique. We have materials which are high performance and very high priced. Ceramics, we have materials which are good performance, but relatively low and low priced in the conventional polymer materials. And this material I encountered 10, 15 years ago, and over time we developed it into a membrane at UCLA. And now at WaterPlanet. And it really offers a lot of performance and economic advantages. So we can achieve something which is a little bit technical, but 4-log virus removal with our membrane, but with an efficiency of a membrane that gets 0 removal of viruses. So the pores of the membrane are about 10 times smaller, but it has the same energy efficiency. So we believe it's truly a breakthrough from a material science perspective, and we're just bringing that technology to market now. I'll show you 2 examples of what we're doing with these technologies. One is in the oil field, and there's mention about agriculture and California. California, I think, is the 4th largest oil producing state in the US, which is a pretty significant amount of oil was spoken to a little bit earlier. So our goal, one of our goals is to take the massive amounts of water that come up with oil and gas, and instead of having that be hauled off and injected into some deep wells and effectively wasted, to clean it up and be able to reuse it in agriculture. And in California, in the Central Valley, there's massive amounts of oil production lying underneath massive amounts of food production. And so the proximity is really the issue. With electricity, you can move it. With water, it's very expensive to move. And so these kinds of water reuse opportunities are really important to have the siting proper. Anyway, the bottom line is we've now treated 10 different produced water samples, oil and gas produced water samples. Our core technology can take the different water qualities coming in, and the controls technology allows the system to adapt and adjust and be able to treat it and clean it all to a standard that it can be safely reused. And we've shared our data with the state of California, and they're going through a review process right now with an expert panel to assess the reuse of produced water in food crop irrigation. So this is a mobile water treatment system. It's in Texas. This company owns 50 or 60 of these trailers, and they go to remote camps, maybe mining, oil and gas, a construction site, and they provide drinking water, and they clean up the wastewater, and they treat the wastewater for reuse, and they're integrating our membrane technology. The bottom line here from this figure is that relative to the state of the art, our membrane is 5 times more efficient, energy efficient per unit of water throughput, and it gives a higher quality of water. So the text shrunk a little bit on this slide, but the takeaway, I think, is that we have the technology, and we talked about distributed a little bit earlier. Well, what do you need? Obviously, you need the total cost of water treatment to justify treatment for reuse purpose. And the technology, for the most part, is there. In most applications, we can treat the water for less than the amount saved by the industrial user. You need intelligent controls because every job is different and the water changes all the time, and conventional hardware can't adapt on its own, and it's difficult for operators to keep up. We need better membranes that are more robust and resistant to fouling, easier to clean, and remote monitoring to enable improved reliability using information technology, cloud-based oversight, and O&M support. And so we've got it all in place, and the question is, together, where can we go with this? So, thank you very much.
I have to start off by saying I really felt twice dissed so far today. One is that I am from San Diego. And the other thing is that I am a card-carrying member of the Fresno Farm Bureau. So I just wanted to make sure that you all understood that. And I did hear somebody mention toilet to tap. You have to also realize that when I worked for the city of San Diego, that was my project. And the San Diego Union Tribune editorial board coined the term toilet to tap. So that was kind of on my watch. I didn't do like Pat Riley did, though, and copyright three-peat. I did not copyright toilet to tap, so unfortunately you guys don't have to pay me every time you say it. So I'm the innovation director at American Water, the id of the organization, as it were. My job is to find cool new stuff that adds value to American Water. Well, there's a delay here, isn't there? So American Water is the largest publicly traded water utility in the United States. You can read all the numbers, and that's why I put it in here so you can look at the slide later. Just suffice it to say that we're about 5% of the retail U.S. water market. What I wanted to talk about is one of the things is our process. What we have been doing since '09 when I started at American Water, focusing on innovation and trying to drive innovation into the organization, is to set up some kind of a process whereby we can move these things through. So this is the latest incarnation of that process, where we go out and we try to find out what it is the folks out in the field want. What does the business need? What do they want? And that's that collection of business intelligence. The numbers you see in each of these boxes, that was as of July 1st. We have a database of companies, and that was just kind of a documentation of how many companies were in each of those steps. So after the collection of the business intelligence, there's this discovery process where we go out. We have as somebody used to say, I have a large Rolodex, and so I talk to a lot of folks out in the industry, find out what they've got. I tend to get quite a few cold calls, and just really see what kind of technologies, what kind of innovations, what kind of products and services are out there, and then see how they fit in with that business intelligence part of the puzzle. The due diligence, we really kind of thinned things down. I've got the same hit rate as a VC, about 2 or 3%, so you really have to quickly thin down because most of the stuff you see is junk. And do some initial due diligence from a technical efficacy and a value proposition perspective. Not a huge amount of work, but enough to say, yeah, this has some potential, not only in and of itself, but also within our enterprise. Then this idea of enterprise fitness evaluation. Does this product or service fit into what we are doing now, what we're planning on doing? How does it fit into the grand scheme of things? Because there's a lot of work going on within the organization. For example, we're just looking at using augmented reality and virtual reality in training and safety type of activity. So one of the things that we in the innovation group had to learn was, well, what are we doing now from a training and safety perspective? How do we do it now so that we could see if this kind of innovation could fit into that protocol and add some value there? After we go through those steps, we go into the validation testing mode, and that's really where the rubber hits the road. We want to test these new products and services in our data, in our asset base, in a real life situation. We want to see if it works. We want the operators to operate it. We want the engineers to design it. We want to really run it through its paces so at the end of the day, we can say, yes, this product met the success criteria that we laid out, the technical efficacy, what it had to accomplish, and what's the price it had to come in at. And if it doesn't meet those criteria, there's a quid pro quo, there's a commitment to buy. So that's how we make sure that the entrepreneur and the innovator has there's a pot of gold at the end of the rainbow, assuming it works. After we kind of do that validation testing, we're into the business case development, and that's really looking at, okay, taking that data and looking at the entirety of our organization and making sure that, or seeing what that total value could be if we rolled it out, whether it's the entire organization, whether it's only part of the organization, and really understand the value proposition, and then go ahead and implement that to as many places as makes sense. So that's the general process that we follow. It has resulted in some significant products and services and innovations being implemented at American Water. So the first one is the smart metering system, and it's really, in essence, a piece of middleware. The artifact was American Water buys, back in 2009, $50 million worth of water meters a year. We were tied into one vendor. We needed some way to merge and have different meters within the same, 2 minutes. I saw the 2 minutes and wrap up signs so the cows come home. You think I'm going to listen to you about that? I mean, come on. Yeah. But sorry about that. I had to give him some attention. Everybody else was ignoring him. So the idea here was that, some kind of way, universal transceiver, some way to have, one receiving component that could read everybody's meters, bring that data back, aggregate it, and deliver it back into our billing system. So in this particular case, we ended up with a piece of middleware just because of many different issues. As we're moving on from here now we're beginning to look at different communication protocols like LoRa, low power wide area networks. We're even looking at using airborne drones to read meters during flybys. So we're really developing the way that we can collect the data from the distribution system, and not just the meters. We expect there to be a significant amount of data that we're collecting, water quality data, flow data, whatever it happens to be, from the distribution system, and it's going to be a matter of getting that data back and aggregated so that we can take some actionable knowledge on it. We're working with a South Korean pipe manufacturer looking at this new formulation of PVC pipe where you can literally run it over with a tractor multiple times and it just kind of springs back into place. So it's much more robust. It's not as brittle as typical PVC. One of the things I really like about this material is that literally you can freeze water inside the pipe and the pipe won't break. I mean, that is really a significant improvement over all the other formulations of the PVC pipe, and the price is consistent or equivalent to existing PVC pipe now. Algae control, algae is becoming a big deal. We're working with a Dutch company with an ultrasonic algae killer. It doesn't really kill them, but and so one of the things you're looking at there is trying to manage the algae populations without the use of chemicals. And so if you can merge that, because this gets you to about maybe 75% algae reduction, if you can merge that with better treatment options or activated, biologically active carbon filters, you can then manage the taste and odor compounds and really achieve some really good results in minimizing the use of chemicals. The source water awareness project, which is Corona Environmental, came out of the Freedom Ministry spill in West Virginia, where I don't remember the name of the material, but it was spilled into the river. And which was interesting is the only reason anyone really, or even knew it was there, was the material smelled like licorice. So without that odor component, that whole event would never have happened. Anyway, so part of what happened in West Virginia was laws were passed that said that you have to kind of document where all the above ground storage containers are, what the potential risk is if there's a spill of any kind, and so these are some of the kind of things that we're working on with Corona. This energy efficient wastewater treatment process, we are actually promoting the growth of different biological material to be able to treat the wastewater at about 50% of the price or the energy cost of conventional treatment. This is in membrane bioreactor system. This is actually a patent that American Water has. In Missouri, they've changed the ammonia discharge rules and lowered them significantly. We have a lot of very small plants where you really can't put a mechanical system on them, so we went out and looked at a number of technologies to be able to accomplish that. We found one that can be installed for maybe 10–15% of the capital cost of a mechanical system. So lots of different things that we're looking at. Biofiltration on granular activated carbon. Typically, we were carrying a chlorine residual across the carbon filters, which was killing everything. What we did is we stopped doing that. The carbon lasted longer. When it grew the biofilms, it actually treated the water better. So by stopping doing something, we ended up extending the life of our filters and getting better treatment. So our goal at the end of the day is to really leapfrog the electric utility industry. The water utility industry has been behind to a significant degree. We don't want to just catch up and do what the electrics are doing. We want to go to the next step, and that's really what the innovation program at American Water is all about. Thank you very much.
Excellent. Thank you very much. So what we're going to do right now, I'm going to put a pin in the last comment that Paul made about, in terms of policy, what could happen. I'd like to have a two-stage question before we bring this out to the audience, and just ask the panel what the role of California might be in their businesses in terms of technologies. And I'm going to ask you the follow-up question after that. If we say that tough times and serious environmental challenges make great innovation. So you look at the cell phone industry emerging out of Scandinavia, you look at the water industry emerging out of Singapore and Israel. California might have the makings of some great economic growth as a result of this. Let me start off with you, Eric. If you look at California without any policy change today, how big a deal is it in your business plan? And where do you see it specifically? Where do you see your next 5, 10, 20 installations?
First, I'm going to correct you. The water industry, really the modern water industry started in California at UCLA.
At UCLA.
Yeah. With the birth of the reverse osmosis membrane 50 years ago, 56.
Correction made.
So California, we started the company here because this is where we live, but California, not just Southern California, seems to have, because it's so big, because it's so diverse, as we've heard all about this morning, we've got all kinds of different industries and they're overlapping and intersecting. We've got water issues, we've got energy issues. It's a really a test bed for the rest of the world. And that's why desal was invented here, because we needed it 50, 60 years ago.
Okay.
And it's you know, it's taken a while, but it's now happening, for better or worse. We are working in California. We're doing a lot of work in Bakersfield with not just oil producers, but food producers, a biodiesel refinery, power plant. Looking at beginning to now do some work more locally here in LA with microbreweries, and the idea that, you know, there's a lot of operations that are out there that use massive amounts of water, you know, ratios of 5, 10, 20 times the amount of wastewater being produced relative to the volume or mass of whatever product they're making. Right? And so the amounts of wastewater that go under the radar in the aggregate from a bunch of small operations, because of the way the regulatory framework is, they're unregulated, they don't have any guidance, they don't know what to do until somebody comes in from the city or county and hits them with a fine. And they're trying to get ahead of that now because they've seen, oh, well, that guy got shut down, or they got hit with $1 million fine last year. So for us, there's a lot of opportunity. It's all about reuse. And when you can find that sweet spot of somebody's pulling in, you know, fresh water or groundwater to help produce their product, and in the course they're making massive amounts of wastewater, and they're paying on the way in, they're paying on the way out. And if we can short circuit that at a cost that is less than overall how much they save by paying less on the way in and less on the way out, then it's a good fit.
Excellent. Okay. Paul, I know that you have a limited ability to work directly with the utilities in California, but from American Water's perspective, what are the technologies that you see deploying in California? What are your top?
You know, it's
three?
interesting. American Water is an East Coast centric company. 60+% of our customers are either in Pennsylvania and New Jersey, but the issues really aren't that different. You're seeing now, you know, drought conditions in New York and New Jersey, so we run into the same kinds of thing. It's really managing the commodity in the best way possible. So what we see in California is kind of, you know, the same kind of things that we'd be interested in really any other place. What I find interesting about California is typically we will, you know, kind of lead the charge. California seems to like to go first. And so, you know, not only from inventing things, but from trying things. And so, you know, for me, a lot of the entrepreneurs and innovators that I run into are out of California, especially on the big data side, especially on the machine learning side. There's a lot of that, you know, kind of the, if you will, the IT kind of technologies. Some of the things we really find interesting are leak detection devices. You know, you can quote all kinds of statistics, but, you know, maybe on average 20% of the water that is produced is lost to leakage before it gets to its customer. And as somebody had mentioned, you have to know really what's going on before you can do anything about it. Part of the problem is a lot of times we don't even know how much water actually leaves the plant. And we certainly, in those areas that we don't even know how much water anybody's particularly using because there are no meters. But as you look at leak detection devices, you know, that, you know, again, you could, the way I like to say it is think of your Ford Motor Company, and you're making F-150 pickup trucks, and 2 out of every 10 of those pickup trucks as they come off the assembly line just disappear, and nobody cares. And so, you know, how can you run a business that way? And that's really the situation that most water utilities find themselves in. So you can work on technologies. There's satellite imaging technologies that can detect leaks, you know, the standard acoustic leak detection type things. There's some really interesting fiber optic sensors that can detect leaks. So there's a lot of very interesting technology now that can identify the leaks and narrow it down pretty clearly where in the pipe, you know, maybe within a meter or so. But that then begs the question, how do you fix the leak? You have to dig the street up. 90% of the cost of fixing a leak is digging up the street. So that brings me to drones, and so you want swimming drones that could go into the pipe and swim around, find the leak, fix the leak, and move on its merry way. If anybody has one of those, see me over by the statue over there. But those are the, so that's the progression of the thinking. You start with, you follow the money. You start with one issue and you kind of see, is there a silver bullet? No. Let's build the system that you need to be able to, run the system better, add some value to your customers, and but again, it's the issues are the same no matter where you are. Certainly in the United States, first world countries.
Okay, excellent. Howard, if you could choose two technologies, what would you say are going to be the next things that happen at SLO?
I think this information data gathering in a much more efficient way, and taking that information, understanding those trends. Here's you're going to be surprised by this second answer. Okay. But the second answer isn't about technology. Mm-hmm. The second answer is actually about the people. Okay. Okay, we can, I look at our frontline staff, our operators, our maintenance people, and all of that, and we can bring these technologies in, but that group, I believe that there's a paradigm shift going there too. So if you ask me and I will tell you in slow, I'm looking for a different type of person. I'm looking for a different type of person and this is no, I've got seniors and I've got young people, it's no diss on an age deal, but the way, if we're going to bring these technologies in, and they're really going to be where the rubber meets the road and there's action on it, it's people that eventually have to run them. Mm-hmm. And so I think within our industry, we really need to seriously think about what does that 21st century operator look like? What does that 21st century maintenance person look like? What does that 21st century manager look like? And I think there's two lines going. Either one by itself, I don't think can be successful. That's interesting.
All right, and give us a statistic on what the percentage of senior water people are retiring.
So I have in my facility 70%. In the next 3 to 5 years, I'm sure anywhere 50 to 65%. Everybody kind of knows it's somewhere in that range, right? So it's interesting. We talk about technologies and I love it. I'm an entrepreneur too, but I also look and go, hey, that's one piece of the puzzle. And when you have this much of your, and it's not just that they're retiring, that's a knowledge loss. And my next thing, so really my next deal on technology, I want technologies that I can transfer that knowledge as quickly as possible. Because as that leaves, there's a huge void. And honestly, we don't have a lot of time. And so there's, hydro at the end, Artemis at the beginning, and different things. But my biggest pressing concern, and I think our industry, is how to make sure we get that transfer of knowledge in a short period of time.
I'm gonna make an observation that I think there's a generation of operators and engineers that have left or are leaving the water industry. I think, like in a lot of other facets of life, artificial intelligence, machine learning, are things in our houses now that are much more appliance-like than they ever used to be. Our cars. Is anybody here, if you've bought a car in the last 5 years and something goes wrong with it, would you even consider lifting the hood and trying to fix it yourself? No, it doesn't happen. A car's an appliance now. You call you bring it to the car dealer, just like when the water heater breaks, you call the water heater guy, right? I mean, very few people are that handy. And I think what the history of the water industry is, it's concrete and sand and steel. It's a big infrastructure, and it's build some holes in the ground and pay some guys, train them up, and pay some folks to run around the clock keeping it up and running and to figure out how to get it to work. And you're throwing chemicals over here, and you're changing out a pump over here, and it's all the time running around. Well, just like we used to have a phone with a coordinate, a camera where you had to get film developed,
That's true.
right? a handwritten address book to keep your contacts. Now we've got a smartphone that does it all. Could any of you fix your smartphone? I can't fix a smartphone if it breaks, right? So directionally, I think where our industry needs to go is for technology to help bridge that gap in the human knowledge loss that's occurring, and to make water technology more appliance-like. And at the end of the day, you can rely on your technology provider, if something goes wrong, to know how to fix it. The operators don't know how to fix everything. You can't replace operators and engineers. Someone's still gonna have to fill a tank full of chemicals, right? Change out the pump bearing set once a year. But you can make technology smarter, and you can bridge those knowledge gaps with technology.
So we're anticipating the world basically is going to have that problem. We've got it earlier here in California than anywhere else.
The other thing is, you got a generation of people that all they know how to do is to function through an app.
So we have no choice.
You got to give them the tools that they know how to use.
To Eric's point, in our facility, everybody has an iPad and everybody has a smartphone. Every single operator maintenance person. That's their main tool they use now. I'm going to tell you a really quick answer. We're doing a $120 million upgrade, and we had a major design firm in there, and we're doing our 30% review, and we're talking about some machinery and O&M costs and life cycle costs, and there was a conference call and probably 40 people involved in the whole thing. I had one of my young operators there, and we're there talking, going, well, you know, we don't know all about this piece of equipment, and we don't know how many are out there, and we don't know the life cycle costs. Within 3 minutes, he went like this, and he nudged me, and he goes, there's all the equipment, Howard, and here's all the graphs. They've already done all that. They've already done the analysis. He found it in 3 minutes, and I looked around the room, and I'm going, I got to be at 5,000 an hour right now at this room, and this young guy just that quick, and so if you provide them the tools and that technology, it's just amazing what they'll do.
And I agree, technology is not the only solution, but I think that the next generation, the wave of smart water technology, not just like smart grid, you know, sensing leaks and things, but all the technology getting smarter, more appliance-like, more user-friendly, the way that everything else in our lives has done over the last 20, 30 years.
Okay, Paul, before we bring this out to the audience for a question, I want to give you the opportunity. If you were king for the day in California and you could wish for a new policy to make things work better for American water utilities in California, what would the single policy change be? And it can't be related to the farms.
Okay.
That's too easy.
You know, I kind of agree with one of the things that a lot of people have said. I think you could have a huge impact if you could literally mandate that, you know, no more wastewater discharge, that it's all got to be beneficially reused. I mean, just start with that, and let people figure out how to do it. I think there's a lot of you could do sewer mining, you could skim, you know, some product off and deliver it into treat it, you know, for golf course, for industrial, those kinds of things. But I think a simple, you know, goal, a simple strategy like that, a simple mandate, you know, would go a huge way towards alleviating, especially managing a lot of the Southern California urban issues. You know, you can do some of that even if you look in, you know, up in Fresno, just recycling, you know, the wastewater up there and using that, you know, for irrigation purposes.
So that also implies that you're talking about conjunctive use permits.
Well, I think there's a like I said, you make the simple mandate, you know, no more ocean discharge. You know, figure it out. But let the marketplace figure it out.
California's been very successful with renewable energy that way.
I don't think you want to dictate how to do things. Mm-hmm. It's just what the goal should be, and then let the marketplace decide. Let the agency people figure it out. Let the industries figure it out, and let the entrepreneurs come in and fill that void. Because now they've got something to shoot for. This is the goal, and here are all the things you have to do. But you know, here are the pieces of the puzzle. I think that would be huge. And I would certainly say you do that before you do seawater desalination, just because it's cheaper.
I have a question to ask, but I'll go to the audience first.
Perfect. Yeah. So ask away. You guys have a cold call now.
It's not a rhetorical question, but it's one that I don't know the answer to, but it's somewhat open-ended. The traditional infrastructure is large centralized treatment plants, be it for water or wastewater. And you've got these vast distribution networks, which we know very little about how they function in reality. And they've been in place for 30, 50, 80 years in a lot of parts of the country. And you see municipalities raising bonds for hundreds of millions to billions of dollars to make major infrastructure investments. And the question I have is, you got a perfectly good treatment plant. It might be projecting 20 years from now, it's going to be undersized. It might be not functioning optimally. And so you want to spend $400 million to upgrade that? Or would you spend $400 million to put treatment at the point of waste generation distributed throughout your entire system and increase the resilience of that system and make the load on that plant lighter, and now all of a sudden it can operate in an optimal mode? Where do we make our investments now and in the future? Do we keep doing it the same way, or is there a different way of doing it which actually creates a synergy of improving resilience along with accommodating the need?
Does anyone have an answer?
Uh-oh.
Okay. A brave soul.
I don't have an answer to that question, but I have a point that reinforces the point about the mandate. In 1990, AB 939 passed and said you have to cut your waste by 50%.
I worked on that at the city of San Diego. I ran the landfills.
And everybody said it'll be the end of the world and we'll all fall off the edge of it. And in fact, every jurisdiction in California eventually made it. Most of us are looking now at zero waste. So the model has been used. It's not a pie in the sky model, and it allows two things to come into play. One is the genius of alternate technology and policy solutions. The other is to recognize that all of California is not the same. Some cities like Santa Monica, where we come from, have the resources to invest in cutting edge approaches. Some have to wait and see what works, and some have different geographic considerations and climate considerations, etc. But it's a big state, but if you set big goals, communities can achieve them.
Right.
Question for Eric would be, if you decentralize it, what do you do about the biosolids? You're treating it, so you're taking something out. What do you do with the stuff you took out?
This is a great technology. This is a great investment opportunities describing here.
I mean, ideally, we already have a large number of not ideally, but in reality, we have a large number of municipal wastewater treatment plants throughout the LA basin that do not handle their solids right now. They send them to Hyperion and Carson. And so there's already a vast networked system for moving the solids from localized points to the large centralized facilities, which through the economies of scale can make the investments in digesters, harvest the biogas. Sorry, what?
How would a neighborhood get it to Carson?
Shovel in a pickup truck.
Could be as simple as hauling. No, it could be as simple as hauling, but it could be part of the installation of a distributed system would be to tie into that network as well. So it's a great question, but it's a solvable problem.
And so there's some very exciting technologies that would create that at small scale, that would create that into beneficial products right there on site. So that's one of the hottest areas for investment right now.
I'm actually also with Santa Monica. I think that the wastewater treatment is probably the next big thing for water also. I think that decentralizing it is an excellent idea. But my concerns with that would be how interconnected the sewer system, at least in the LA region, is. Santa Monica is a small system. We pump about 5 million gallons of LA's wastewater through our city, just up the bluff. So if it's not coordinated in a proper manner, you might have, forgive me for using this euphemism, but Peter stealing from Paul, right? If upstream of us, LA puts in one of these pocket plants, we make that same investment 2 or 3 years later, and then the source dries up, or the quality of the source changes significantly. I mean, being in treatment, how significantly that would change your treatment processes. I think that there would need to be a regional coordination of that to be very successful. So just telling small municipalities to go with these pocket plants while drumming up interest would be really great. I think it needs regional oversight.
I'm going to give you a real life scenario there. So City of San Luis Obispo, Cal Poly University is not in the city limits. And with the carbon mandates and everything that the UC system is under, they're looking for a number of ways to meet those mandates, just as UCLA is. And one of their ideas basically was to put a scalping plant in. And it made sense, except for their wastewater flow comes to us. Now it was a whole different deal on solids content, reduction, and so right to your point, we quickly realized that we as a group, even so they weren't in our city limits, but they fed into our system, and we're getting together and going, is this the best option? Is there some other options? So that very scenario happened. And luckily, lines of communication and vision were good enough that we will have a solution that I think will help both sides, but it just as easily could have went two separate ways. Hey, not our problem. We're just trying to do our mandate. Huge problem for us. Our system wasn't set up for that.
Yeah, just a quick comment that I think you're absolutely right, that there does need to be a lot better regional coordination, period. But to execute on something like what I suggested, obviously there's a lot of stakeholders involved. Just to clarify though, my idea is, let's say a big centralized treatment plant like Hyperion or Carson, if they're gonna spend $400 million, I'm just making this up, to do a plant upgrade, I question the merits of doing it there as opposed to distributing that, in which case they would still own and operate the assets. We've got remote monitoring technology, cloud-based controls approaches that exist now. You don't need someone standing there looking over the thing 24/7. An alarm goes off and you deploy an operator from a centralized location within an hour, 20 minutes, right? So it would be internally coordinated through the entity that raises the bond and does it. I'm just saying the physical infrastructure could be distributed and still networked and connected and smarter than it is now and not need to be manned 24/7.
Okay, can we get one more question in before we clean? Yes.
Hi, thanks for the panel. I'm Rucker Alex from the San Francisco office of AECOM, the Sustainable Economics Group. And I'm curious, to follow up on one of Laura's earlier questions, what policies, programs, or funding are working now to facilitate water innovation in California?
There's over my time here in California, the last 15 years, one of the birth of my career was through Metropolitan Water District's DRIP program. It was the Desalination Research Innovation Partnership, DRIP, called DRIP. And they brought in funding from Department of Water Resources, California Energy Commission, the US EPA, and it was a tremendous program. There were multiple universities involved. There were multiple cities involved. San Diego was involved. And it was fantastic. It led to a tremendous amount of innovation. It gave birth to large diameter reverse osmosis, that funding program. So today the CEC still funds innovation, as does DWR, Department of Water Resources. And there are other entities in the state. EPRI, the Energy Producers Research Institute, actually funds water technology research and pilot testing if it can save energy. Right? So California's a great place to be in terms of state support, local support, regional support. Even some of the water districts, they don't just do their own internal R&D, but they'll partner with tech startups. So there's a lot of opportunity.
Yeah, state revolving fund has been for municipalities of my size have been just been fantastic. It's been a huge help. It's a great bridge.
Excellent. Okay. All right, so I think we're out of time. Thank you very much.